right. Ready to go on?
Yes.
Thank you very much. Yes, Ms. Graham.
Yes, thank you. So I now want to ask you some questions about the fire lift at Grenfell Tower, for which purpose we will mainly be in Appendix L of your report. So as you explained in your presentation in June of this year, the lifts at Grenfell Tower were renovated in 2005.
That's correct.
And that work was carried out by Apex as contractor against a Butler and Young specification.
Correct.
And you say in your report that at that time it was approved document B 2000 that was the relevant statutory guidance under the building regulations.
That's correct.
And you say that approved document B 2000 required conformity to a particular British standard. That's BS 55885 1991, which was the relevant standard at the time of those lift replacement works.
Yes.
Now, you say in your report that the Butler and Young specification did not provide for a full firefighting lift. We're going to look at the difference between that and a fire lift in a moment, but I just want to be clear. So it was not specified to be a full firefighting lift. Is that right?
That's correct, based on the evidence provided to me.
Yeah. And nor did it specify compliance with that British standard I just referred to. You make that point in your report.
Yes, I
as well.
did make that point.
And you note that despite the TMO's policy that when the lifts are being refurbished, the reinstalled lift should be upgraded to a firefighter lift, the lift was not upgraded to that standard, but was replaced with another fire lift. Is that correct?
That's correct.
Now, can we just go back to CP3 1971 and just look at what a fire lift was required to have under that standard?
Yes.
So if we go to figure L.2 in your report, BLAS 5033 at page 10. If we can just, yeah, thank you. So here you've given the kind of basic fire lift requirements as per that standard in 1971.
Yes.
And you've got them in labels here.
Yes, that's correct.
So we've got an independent power supply, various things about cabling, serving every residential level,
Yes.
and then a fire switch at access level. Is
That's
that right?
correct, yes.
So that was a fire switch to enable it to be taken into firefighter control.
That's
is that
correct.
So that's, and we've got a minimum lift car area. That's a basic fire lift. Is that correct?
Basic
What we see there,
Well,
or-
they give
vary. Yeah.
dimensions are made clear.
Yeah.
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 And also it should serve every residential level, and then there's a walking distance to the door of the lift.
Yeah. Now, can we just look, you've put the features of a full firefighting lift in a figure L1 of your report, where we see those in diagram form. That's on page 7 within chapter 33.
Yes.
Perhaps if we can pull that up. And again, so you went through a number of these features in your presentation in June.
I did.
This is just to remind ourselves of what a full firefighting lift requires.
Yes, so it... oh, sorry.
Yeah, I mean, take it from the top. An independent primary and secondary power supply. Is
That's
that
correct.
a key feature?
Yes, it's a key feature to ensure operation in an emergency.
Water ingress protection. I
Again,
think that's the fourth
On the
label
left
down
there.
on the left.
Yes.
I'm just highlighting some of the key features. We've got them all in labels here. The provision of an escape hatch within the lift car.
Yes, for the fire brigade and others, yes.
A compliant intercom system. So you've got you talk about a two-way intercom from the lift car to the machine room and access level.
Exactly, so you can communicate with someone outside the lift or for other reasons up at the machine room. Yeah.
And again, we also see the fire switch at access level.
Yes, and fire-resisting landing doors. Yeah.
Yeah. So those are all the features if you were to do a firefighting lift.
Yes, I mean that's a summary of a longer British standard.
Yeah.
So yes.
And you've also noted in your report that the TMO has its own definition of a firefighting lift. And what you say is that doesn't replicate the provisions of any design standard that you're aware of.
As I read it, I don't know the basis for their definition.
Now, what you said is, even looking at the lower fire lift standards, you've seen no evidence that in 2005 both lifts were connected to fire control switches. Is that correct?
In 2005,
yes.
Or to the 2005 standard?
Yeah, in 2005, you say you found no evidence that the lifts were connected to fire control switches. You say the Butler and Young specification did not specify the provision of a fireman's control to any specific code or guidance. Is that correct?
Yes, that's correct. Not that I didn't find physical evidence of.
Yeah.
Sorry, I misunderstood.
No,
yes.
I think it's my question.
Yes.
And you've also noted that the relevant British standard, the one we referred to earlier, BS 55885 1991, required some very particular features for the firefighting switch operation. Is that correct?
Yes, it did.
Now, you've set these out at paragraph L 3.3.6 and following of your report.
Yes.
Perhaps we can just bring that up on screen. We don't need to go through all the details of it, but it's at BLAS 5033, pages 12 and then on to 13, if we do page 12 first. So I think at the bottom of that page, you've included all the different
so it's the next
requirements
page.
for a firefighting lift switch. Sorry, yeah, it goes on to the next page.
Yeah. Oh. Yes, this list here.
So there's a long list here, but if I can just try and understand in summary what you're saying this shows. In essence, is it right that such a switch should enable the firefighters to bring the lift back to their access level and then take control of the lift?
Yes, and prevent its use by any other person from a lobby.
Exactly. So it's taken out of all normal operation.
Exactly.
So if you're a resident on floor 10 and you press the switch,
it
shouldn't respond to that.
Exactly. And if you happen to have pressed the switch and you're waiting and the lift was taken under control whilst you were waiting, again, it wouldn't respond to your earlier call.
And the way in which the firefighters control the lift is by putting pressure on certain switches within the lift car itself?
Yeah, so in that standard, once it comes to where the fire control point is, and then the fire brigade can enter that lift and use the keys inside, use the buttons inside the lift car to go to a floor and open the door slowly on that floor.
Yeah. So it's basically under complete sole firefighter control.
Yes,
if
it should
that
be.
lift switch works.
Yes, that's correct.
Yeah. And you've noted in your inspections at Grenfell Tower, as it existed at the time of the fire, that there are 2 fireman's control switches.
Yes, I did.
There's one at ground floor.
Yes, and one at level 2.
Yes. Let's just go to photographs of those. This is figure L11, BLAS 5033 at page 25. So there we can see the switch that was present on ground level.
Yes.
Yes. And the switch at level 2.
That's correct.
And they've both got fire control written on them. They're
different shapes.
Slightly different shapes. Yeah. And what you've said in your report, is this right, is that you don't know if one or both of the switches at ground and level 2 were kept in 2005, or if they were new,
Exactly.
or if there was a change during the refurbishment. You're a little bit unclear about the history of these switches.
Exactly. So there should only be one, because there's no way of understanding which, if one has, if there's not meant to be 2, and if there is 2, which one takes priority, okay? And I've reviewed all sorts of documentation, so when I say I don't know, it's not from want of trying to find the information as such. And I don't know which switch was installed in 2005, or if one was added during the primary refurbishment, or if they both existed before 2005, or they were both new or both old. Apologies for rambling, but it's a rambly subject. So in short, I have no idea when each switch was installed at any stage.
Yeah. Now we're going to come back to these switches in a moment, but in the principal refurbishment, you've ascertained that the extent of the work that were carried out to the lifts was basically 2 new landing doors to the lift shafts on levels 1 and 2.
Yes.
Because of the new flats that were being converted in terms of change of use at that time.
Exactly, works to allow it to stop, to allow the lifts to stop at every floor. And
you've mentioned, I think, L4.3.8 of your report, what the extent of that work was, and you say that the scope of work did not include fire control switches at this time, in terms of what you can ascertain. Is that correct?
Based on the evidence provided to me, yes.
Yeah. Now, in terms of the lift's performance on the night, what you've concluded is that the basic fire lift function, the override switch we were just looking at, did not work on the night. Is that correct?
Yes. So when I wrote my first draft of this report, the evidence from the firefighters was a key was placed at the ground floor fire control key point, and they considered that nothing happened.
Yeah, we're going to come to this. So just in terms of the switch on the ground floor, as you've just said, we know that Firefighter Secret tried to use a drop key to activate it,
yes,
but couldn't get the lift to return to ground when he attempted to operate the override switch. We can see an image of that if we go in your report BLAS 5033 at page 39, figure L20.
Yes.
And if we blow that figure up, so there we see Firefighter Secret, and he's put a key into the switch.
Yes.
Is that what we can see? And that's what you're referring to?
Yes, I am.
In your report.
And then his evidence that nothing happened.
Yeah. Now, you also note that the lift remained in general operation and was used by residents during the fire.
Yes, based on the evidence from the night.
Again, we'll come back to that. Now, you now have, and you had at the time of writing your revised report, the benefit of a report from WSP,
yes,
which was prepared for the Metropolitan Police Service.
That's correct.
And we'll look at some aspects of that report in a moment, but just to summarise, that report, first of all, shows that the level 2 override switch had no wires connected to the fireman's switch.
That's correct.
So that level 2 switch, which is still there, doesn't look like it was connected.
Exactly, and if it was not connected, as an absolute minimum, notification should have been present in that location for the fire brigade, but far more preferably, that switch should have been removed.
Now, WSP also state in the report that they tried to activate the fireman's switch on the ground floor and it was, quotes, difficult to operate.
That's correct.
So is your understanding that they did try and operate it as part of their investigation?
Yes, they did. I've read their activities. They tried to place the drop key in the wall, and they also removed the box mechanism from the wall and made further attempts there.
Yes.
And neither were successful because the mechanism is jammed or seized. It can't be moved. Oh, yeah.
We can go to that in the report. So they removed the faceplate, so they did a destructive examination.
Yes, they went and looked at the innards of it all. Yeah.
And they say they discovered that the mechanism was seized and damaged stroke deformed.
Yes.
Can we just look at that? So that's figure L18, BLAS 5033, pages 31 to 32. So the left here is the level 2 switch with the faceplate removed, where they found the wires were not connected, is that
yes,
correct?
that's correct.
And the right is the ground level switch with the faceplate removed.
Yes, and the mechanisms at the back there hanging down.
And they found that to be deformed and damaged.
Yes, I'll have to rely on their physical activity on site, which I'm
Yeah.
happy to do so. Yeah.
Yeah. And do you think that that's consistent with the evidence of Firefighter Secret as to the problems he encountered with activating the switch on the night?
I very much do, yes.
And do you think it signifies a potential maintenance failure with the switch in terms of maintaining it?
There is a duty to test those switches, a duty to understand if they're connected or not. And so, yes, there is a duty to maintain life safety equipment at all times in any building.
Do you think it's possible that the reason Firefighter Secret could not operate the switch is that he was using a drop key which didn't have a pin across it to stop the pin going too far into the access point?
No, I do not.
And can you just explain why you don't? Is that because of other evidence you've seen?
I have other evidence has been provided to me, and when the drop key is in the correct position in a mechanism the same as Grenfell Tower, there is no need for the key to be pushed as far as hitting off that split pin. So it's in the correct position, and then there's a gap, and then there's the split pin. So you can't push it further. I don't understand, therefore I don't understand the relevance of the split pin in that evidence sent in.
And you've also said in your report that it remains unclear to you whether that ground floor override switch, which does seem to have been wired at that point,
yes,
was in fact interfaced with the lift controllers in the lift plant room, and if interfaced, whether it was operable.
Yes, so again, WSP have various findings from site, and as a result of their observations, I actually don't know now if both lifts or one lift is a fire lift, which one was connected to the key switch, and therefore how everything was meant to work, both and one, and if it was one, which one was it?
Yeah.
The drop key has a mechanical operation, does it? It's not it doesn't have any form of electrical.
It's in itself mechanical, but as my understanding is then it forms some kind of circuit, and that should then be connected to an interface somewhere else, which would send a signal absolutely outside my area, electrical engineering, absolutely outside my area of expertise.
I couldn't help noticing in one of the earlier pictures,
yes,
someone seemed to be holding what might be a drop key. Would you recognise one if you saw it?
Oh, I would, yes.
Right.
I even
Could
brought,
you
I
if you
brought
go
a
to figure
brochure for you. with
L11,
in it, yeah.
Go to figure L11, BLAS
Yes.
5033 at page 25.
Yeah. So every lift expert in the country will be cross when I describe it this way.
That's all right, do your best. That's
a drop key for the old style control.
Right.
And you can see, sorry.
Yeah.
That's because this portion drops, you push it in on the horizontal and it drops down once it gets to the right part for it to drop down in behind this plate. And that's the old style express key, they're called as well.
All right, thank you.
Yeah.
The point
and it's
before,
well illustrated in the WSP report.
Yeah.
that point about the interfacing and whether this switch was interfaced with the lift controllers, is that something you think could be investigated further?
I think it very much needs to be investigated to consider a considerable detail.
And this is probably a good point to note, isn't it, that you have recommended in your latest report that the inquiry should appoint a specialist lift expert to look at this.
Yes, I do, because we're getting into the complex question of what's connected, where, how, why. And there, WSP also found some curious connections where it may have been connected to the detection system linked to the smoke control panel, which I don't understand at all. So those interfaces from the lift are very important to understand now.
Yeah. just a couple of questions about the lift as a mode of evacuation for those with mobility problems.
Yeah.
You consider that Grenfell Tower was non-compliant with the B1 means of escape provision. And in particular, you say that approved document B does not make specific requirements, but that you think B1 would require an adequate means of escape for those who have mobility problems. Is that correct?
Yeah, so the functional requirement is clear that everyone can evacuate the building independently without assistance. The statutory guidance then doesn't make any specific provision in residential buildings for those that require assistance.
And you've noted in your report that approved document B 2010 states that those in wheelchairs will need evacuation by lifts, and in particular paragraph 5.39 of ADB allows for a firefighter lift to be used to evacuate those with mobility problems.
That's correct.
So that's there in that guidance.
It is, and that's a common means of providing assistance, using the firefighting lift with all the additional protection measures whilst it's available.
But you note that in the event the lifts could not be used for that purpose because they were not these upgraded firefighter lifts.
Exactly. They don't have the right emergency power sources and other protection measures to make them safe enough to be used to transport people around the tower. That's correct.
Now, you are aware of some of the issues which arose on the night, given that the operation of the lift stayed in normal mode.
Yes,
including, firefighter Badillo talks about getting stuck on the 15th when trying to go to the 20th.
Yes.
We've also had evidence from Nadia Jafari about what happened to her father in relation to the lift.
Yes.
Do you think that, given that the lift couldn't be used as a firefighter lift or even a fire lift on the night, then it should have been disabled in the early stages of the fire to avoid the consequences of it being in normal operation?
Disabled by whom and how? Oh, sorry,
that's the question. Yeah.
Should
possibly
have been disabled. Well, frankly, if I may say, it shouldn't have been provided in that condition in the first place, and that should have been known. What about I take that point, but in terms of on the night, do you think it might have been possible to say block the doors with firefighter equipment and take it out of operation? Is that something that could have happened? I just think, I've never tried to block a lift with firefighting equipment. I did observe it being done in the early stages. You can see that in the CCTV. As to the practicalities of a fire brigade attempting to do that with equipment in the middle of an event like this, I think others should comment. But for me, the primary duty was not to provide lifts in that condition in the first place.
Can I take it that you're not yourself aware of any way in which the lift could have been put out of operation by having the power disconnected or any other way that would be reasonably accessible?
I would prefer you to ask a lift expert that question, and then it's who do you phone, what do they do, how do they get there? A very interesting concept that a proper lift expert could answer all those questions.
Yeah, thank you. Now, in terms of the use of the lifts in the very early stages to fight the fire in flat 16, you say in your report that the fact it was not a firefighter lift may have caused a short delay in arriving at flat 16. However, you've also noted in your report that given that firefighters did actually use the lifts in the event to transport equipment up to the bridgehead in normal mode, you don't think this caused a delay to the initial firefighting response?
It doesn't seem to have been significant, no, in terms of time as they relay events.
Yeah. Just one final set of questions on this topic. Do you agree that when considering whether the fact that the lifts were not firefighting lifts made a difference on the night, it may be relevant, for example, that the LFB policy was that the bridgehead is set up 2 floors below the fire floor, and that the policy is that lifts should not be used above the bridgehead in a high-rise incident? Do you think those are potentially relevant in terms of the impact of not having a firefighter lift?
Yes, I do. Yes, I do.
The lifts appear to fill with smoke at a fairly early stage when they were opened with lobbies. Does that mean that using it for firefighting on the night may have been compromised.
Yes, it is, and I think I've been thinking about that actually. I think the overall flow of smoke through the building, when that's being considered, there's an interesting sudden change in state in the lifts when you look at the CCTV, and I would love to understand that to a much more substantial level of detail than I do at the moment. It's a very sudden change in state, and I'd like to understand what caused that. Was there some kind of pressure or flow situation going on in the building caused by other matters? I think that would be a very interesting and useful study to do.
Yeah.
Just to point out, remember that the lift shaft should also be provided with a supply of clean air in a standard pressurization system, so we'll get on to that.
Yeah.
So it's all interconnected where the smoke was flowing. In terms of the lifts also.
In the light of those points that we've just been discussing, do you agree that the fact that the lifts were not firefighting lifts made no difference or no material difference to the development of the fire in terms of the ability of the firefighters to carry out firefighting?
In the early stages of the fire? Or any stage?
At any stage.
I wouldn't want to try and answer that question.
Okay, fine. I then want to turn to the smoke ventilation system.
Okay.
And at this point, it's going to be Appendix J, which is worth having. And what I'd like to do, 'cause this is a potentially quite a complex topic, but is to start by looking back at some of the slides from your presentation back on the 18th of June, just to give a very overall picture of how the system was configured. So if we look at BLA 405481 and go to page 173 of that presentation.
Yes.
So here what you've given, I think, is a schematic which shows the operation of the original smoke control system. That's original as in from the 1970s when Grenfell Tower was built. And can you just explain very briefly how that original system was intended to work?
Yes, so in the event of a fire in a flat, once that flat door was opened, smoke would enter the lobby and would be extracted up to the roof by the shafts on the north side of the lobby, and fresh air was supplied into the south side of the lobby.
So it's a simple kind of flow of air.
Yes,
from
it's a very simple
base
extract.
Yeah.
Very simple extract system.
Yeah.
It's important to note the original system was a natural system first.
Yeah.
So the vents opened and the smoke moved by buoyancy first, and then there was a control for the fire brigade to use where they could switch it to being a mechanical system then, and then the fans would operate and extract the smoke.
Yeah.
So it was natural ventilation until the fire brigade switched on a mechanical extract system.
Yeah. And is that what is termed a corridor smoke dispersal system?
A dispersal, yeah, so a dispersal system means you have a means of dispersing the smoke from the lobby.
Yeah. And it was designed to work on one floor only at that point?
Yes, that's correct.
Yeah. If we then go within this presentation to page 179.
Yeah.
So if we can just... So then you make it clear here. So what we have, and we'll follow this through in a moment, is now in Grenfell Tower, at the time of the fire, there was a combined lobby environmental system and a smoke control system.
Yeah,
Is
that's
that
correct. So there became a need for environmental air control because of the new services placed through the lobby, which could cause a build-up of heat in normal conditions. And so a decision was made to make the existing system a combined environmental and smoke extract system. So day to day, the system was used to deal with temperature build-up in the lobbies, and then in an emergency, it was to switch over and become a means of smoke control only.
Yeah. And again, it's designed to work on one floor only in smoke control mode.
Yeah.
And can you just very briefly, again, because we'll get into this, in environmental mode, how is it meant to work?
In environmental mode, there is a supply. There's a supply of air, fresh air in at level 2 that comes up and out on the vents on the south side, and then the heat is removed. So that's supplying fresh air, and then the heat is removed by means of an environmental fan at the roof up through the north side vents.
Yeah. And then in smoke control mode, just overview.
Yes.
In contrast, how is it supposed to work in smoke control mode?
So that mode of operation has to switch off, and then you extract smoke in 2 directions, down and out at level 2, and up and out at the roof.
Yeah. Now, is it right that during the refurbishment, 2012 to 2016, new features were introduced to the existing smoke ventilation system?
Yes, that's correct. So new fans, new dampers.
Now you've listed all those out. Let's just look at that. At J6.5.2 at BLAS 5031, pages 52 to 53. So again, we don't need to go to all of these, but I just wanted to pull out some of the features. What you've done here in this section of your report is to explain all the new features that came in at the time that the smoke vent system was refurbished.
Yeah, so the existing, they're called builder's ducts. They're, instead of being metal, they're formed with blocks or concrete. The existing builder's ducts were maintained, 2 on either side of the lobby, north side and south side. And then new equipment was installed into the tower. So you've got the 4 automatically openable vents or fire dampers, the dampers at every lobby. There was a new extract fan combined with the environmental fan placed up at the roof level. And then there was new extract fans and new environmental fan down at level 2. And then down at those lower levels, a series of dampers also to allow environmental mode and smoke mode to be it was meant to be fully separated at level 2. And there was the need for some new ductwork at level 2 also to bring the system out to the external wall. Yeah.
And then I think as you go on and explain over the page, there was a number of other things, including new controls, control panels, detectors, which we will come back to. So there were a whole lot of new electronic control panels that were introduced.
Exactly. It's called a human machine interface panel out in the main lobby, which allows day-to-day or emergency interaction with the system, and then a more complex control panel in, I think it's the hub room it's called.
And is it right that both the original system that was there in the 70s and the refurbished system with all this new work, that they were both bespoke systems combining an environmental ventilation system with that they were both bespoke systems?
Okay, so the original system had a smaller area of vents for natural ventilation than CP3 called for.
I'm coming to that,
Oh, was I just meant to say yes? Sorry, yes, no. Sorry, yes. Well, just ask me the question again.
No,
so
were
I
they
can
both
give the
bespoke?
appropriate answer.
Were they both bespoke systems?
Yes, but there's a lot of caveats
Yeah,
there. I
sorry.
can't
Yeah,
quite
yeah,
say
yeah.
yes. Yeah, so yes, nearly they
Yeah.
were. Yeah.
Just in terms of that combining the environmental system and the smoke extract system, is it common for both systems to be combined? Do we see that in other buildings?
You can see it in other buildings,
Yeah.
but I'm relying on Max Fordham said it was unusual in their paperwork.
Okay.
But it would be a lie to say it's never been done before.
Yeah.
It is done.
Yeah. And is it common that sometimes both systems can share the same shafts? Is that common?
It's not very common.
Okay.
Can I just make sure I've understood
Yes.
what's going on here? The north side
Yes.
vents and trunking
Yes.
was essentially always there,
It was always there.
and it was
yes.
always an exhaust system to the roof.
Yes.
The south side started life as an inflow system
Yes.
and had to be changed as a result of the refurbishment
Indeed.
to an outflow system.
Yes, it had to do two things after the refurbishment.
So when the system was operating in, what do you call it, ventilation or
Environmental mode.
mode,
Yes.
what was the south system doing?
It was supplying, there was a supply fan at level 2 taking air from outside the building
Right,
and
so-
pushing it up. If you imagine
So
pushing that
it was
fresh air
doing the
up.
same job as it was before. It was feeding air into the system.
Yes, but for environmental reasons
Sure,
only.
sure.
Correct, yes.
Now, I probably want to know the answer to this, but I don't off the top of my head.
Yeah.
When it changed into smoke
Yes.
extract system, did the fan on the south side simply turn the other way? Or was there a second fan
There is
that
a
operated?
second fan.
Right.
So the environmental fan switches off. The dampers go into a specific arrangement
Yeah.
to seal that
Thank
part of the system. And then your extract fan goes on,
Yeah.
the dampers open, and now you can pull
And you-
the smoke down.
And you presumably got a second line of trunking between, at some point,
At some point,
in which the extract fan is operating.
that's correct.
Right.
They shared a lot of that. There's a good drawing in my
Yeah.
report. I don't know if you want to look at
Yeah,
it,
we're
but they
gonna-
did share some of the ductwork
Yeah.
there. And the dampers were placed to separate the two fans.
No, I think I
Yeah.
understand the
Yes.
basic.
Yeah.
But in
we are-
essence, it's meant to separate,
Yeah.
and then the extract fan and ductwork are safely used to extract smoke, or that switches off, and you go back to opening up the right piece of ductwork to the supply fan and operate in environmental mode.
Thank you very much.
Yeah, I think we're going to come to that diagram in a moment. Just going back to the original system, I think you've just said this. So you've said the key reason why you think the original system didn't comply with CP 371
Yeah.
was that there was an inadequate aggregate area of the smoke shafts. You've said that the aggregate area was significantly lower than the area recommended. It was only about 0.48 metres squared, whereas it should have been 1.5 metres squared.
Yeah, that's
Is that correct? And could that make a difference to the operation of the system when you don't have the right aggregate area?
Yes, there's less. I suppose the best way of putting it is that there's less room for the smoke to flow out under buoyancy and get to the top of the building.
Yeah. So then let's come to the newly refurbished smoke control system. You have, in your Appendix J, assessed that system in accordance with the guidance in Approved Document B,
Yes, I have.
2013. And do you agree that the design basis assumed in Approved Document B for a smoke control system is on the basis of a fire starting in a single location and being contained within a single apartment?
Yes, I do.
So consequently, a smoke control system designed in accordance with that guidance would only be required to disperse smoke from a single common lobby, not in multiple lobbies on multiple levels.
That's correct.
Now, Section 2.27 of Approved Document B 2013 gives us an alternative to the natural ventilation route to compliance, a mechanical option using pressure differentials. Is that correct?
Yeah, so there's natural, there's mechanical, and there's pressure differentials, which is a form of mechanical.
And
there are other mechanical types.
We're going to look at the differences between those in a moment. Can we just look at approved document B 2013? That's CLG 50224 on page 28. And I just want to start. Sorry, it's internal page 28, so that's 2 pages up, I think, from this. Yeah, and I just want to start by looking at the bottom right-hand column, smoke control of common escape routes, 225, right at the very bottom. So this, I think, tells you the purpose of providing smoke control. So it says, despite the provisions described in this approved document, it's probable that some smoke will get into a common corridor or lobby from a fire in a flat, if only because the entrance door will be open when the occupants escape.
That's correct.
And then if we can go on to the next page, if we can just highlight the top of that page to start with. So it says, there should therefore be some means of ventilating the common corridors or lobbies to control smoke and so protect the common stairs. This offers additional protection to that provided by the fire doors to the stair. And then we see this. This can be achieved by either natural means or in accordance with paragraph 2.26, or by means of a mechanical ventilation as described in paragraph 2.27.
That's correct.
If we can then look at paragraph 2.27 on that same page. So there it says, as an alternative to the natural ventilation provisions in paragraph 2.26, mechanical ventilation to the stair and or corridor lobby may be provided to protect the stairs from smoke. Guidance on using the design of smoke control systems using pressure differentials is available in BSEN 121016 2005.
That's correct.
So those are the key parts of approved document B. Is that correct? And so it's directing the reader to the guidance in that British standard for pressure differential systems.
If one is going to design based on pressure differentials.
So just pausing there, and I know you were just touching on it. Can you just first explain the difference between a natural ventilation and a mechanical ventilation system?
Okay. So just in very, very, very simplistic terms, and it's, again, that these things are explained in substantially more detail in various British standards. So natural smoke extract system is providing an opening so smoke can leave the space by means of its own natural buoyancy whilst hot. A mechanical system is using fans to extract smoke from the fire zone. A pressure differential system is somewhat different. It does use mechanical devices, but it isn't to extract smoke from the fire zone. It's to stop the smoke from leaving the fire zone. So it's really important that I make clear that there is a difference between a mechanical system and a pressure differential system and what they're trying to do. So when you provide fans and other devices for a pressure differential system, your goal only is to stop the smoke leaving the fire zone. It isn't to remove the smoke from the fire zone.
So you're what? Raising the pressure in the lobby in this case?
Well, I'm afraid I can't say that here.
No, I just get the concept.
The concept is you raise the pressure in a protected zone to stop the smoke leaving the fire zone.
And effectively, if there's leakage, it's going to be of clean air into the fire zone.
It's yes.
So you wouldn't have the sort of grills and trunking that we've got on the north side, which is simply letting air escape to the outside.
Can I answer that question a little bit later?
I think that some of the diagrams we're about to come to is
so there's Grenfell Tower, and then there's a pressurization and depressurization system as it should be done.
Very simple, well, it may not be simple, but I've come across this in the context, for example, of laboratories handling
Yes.
dangerous materials.
Yes.
So you pressurise the laboratory to keep the air out.
Exactly. Exactly. That's what should happen.
Yeah.
And so the location of your equipment must be in the right place to allow you to pressurise the right zone to prevent the products of combustion leaving the fire zone.
Yeah.
Exactly.
So just to be clear, a pressurised system, that could be pressurisation of the stair and the lobby and the lift shaft. That's the protected space is pressurised relative to the fire zone or flats. Is that right?
So there's two types of pressure differential system. One where you pressurise and one where you depressurise. And I'd really love to be able to refer to some diagrams while I explain this.
Yeah. So is this the point where you wanted to refer to your sketches?
I would like to, because it's.
So,
I do think it's fiendishly complex to understand.
If we go to BLAS 5038, I think what you've done is that for the purpose of your oral evidence, you've prepared some very basic cartoons or sketches to try and help you explain this. Is that correct?
Yeah.
BLAS 5038. Sorry.
Yeah.
Yeah. So
Okay.
can you just talk us through this slide?
So a pressure differential system comes in two forms: pressurization system and a depressurization system. And in a pressurization system, air is supplied into the lift, it's supplied into the lobby, and it's supplied into the stair. Okay? And the idea then is when you open the fire zone door, the products of combustion are prevented from leaving. Okay, so that's a pressurization system. So if I'm able to look at the next one. Okay, so it's important to understand that a depressurization system in the British standard is typically recommended for basements only, where the fire zone is sealed. And there the idea is you extract the products of combustion from the fire zone at a rate that when you open this door, because of air supply in the protected space, again, the products of combustion cannot leave the fire zone. So you have your pressure differential, but the extract rates and design here are not to remove the products of combustion completely from the fire zone. It's at enough of a rate with the pressure differential to prevent the smoke flowing out onto the lobby, mainly. Okay. So pressurization, all the equipment focuses on the protected escape route. Depressurization, it's meant to focus on the fire zone to prevent smoke leaving the fire zone going out to the lobby.
Right.
Do you want to, I think it's worth sticking with these. Do you want to go through your next
if
slides?
I can see the next one.
So can you just explain, this is the Grenfell
Yes.
smoke ventilation system.
Okay.
Is that right, that you're trying to illustrate?
So here I'm trying to explain that at Grenfell Tower we appear to have a depressurization system, but it isn't installed to deal with the fire zone. Instead, it is installed to deal with the lobby. Okay, and what that means, because of that pressure differential and the focus being the lobby, once you open the fire zone door, the products of combustion are attracted out to the location of where the equipment is extracting from the lobby. Okay.
And I think there's another slide that completes this run. It's the next. It's not the next page, because the next page is blank, I think.
Yeah.
But
No, that's fine.
Yeah, that slide.
So actually, can we just go back to the other slide? Sorry. So at Grenfell, the system is designed that there is an extract rate from the lobby, and the system is balanced such that when you open this one stair door, the idea is the airflow across that door should prevent smoke moving from the lobby to the stair. But it assumed every other door was closed in making the calculations for that. When we go to the next slide, once you open a second door, the area of opening, if you like, increases, and so you can't maintain the necessary airflow across one door, because now you've two doors open, and also the extract is pulling the smoke from the fire zone out. So it causes two things: attracting the smoke out and reducing the ability to maintain the required airflow at that door, because a second door has been open.
And just a few questions to build up to your preliminary views about this. So is it right that in all types of smoke control system, vents on the fire floor are opened and vents on all other floors are closed in order to allow the full capacity of the smoke control system to be directed at a single floor?
Typically, yes.
Can you just explain for us why it is you've assessed the compliance of the system at this stage against the requirements of BSEN 121016 2005, the British standard that we saw in ADB?
Yes. Because in the PSB documentation, it refers to some specific criteria from the pressure differential standard.
So in the documentation you've seen, it's referring to some of the
yes, it does.
criteria that are in that British standard?
Yes, it does.
And that's a British standard for pressure differential systems?
Yes. But it isn't called a depressurization. It wasn't called a depressurization system in the documentation dated from before the fire.
Yeah, so that's what I was coming on to. So it's clearly not a pressurization system. Do you think it was a depressurization system? In
the sense that there is extract from a zone relative to the fire zone, and a stated attempt in the documentation to provide a pressure differential across a particular door and provide a flow rate across the stair door, and looking at the ability to open a door. And they're all features of the design basis using pressure differentials.
Yeah. And is it right that that pressure differential between the stairs and the lobby that you were just talking about was minus 25 PA? Is that right?
That's stated in the documentation.
Yeah. What does PA stand for?
Oh, pascals. Ooh.
Yeah.
Yes, pascals.
And is that a unit used to measure pressure equal to 1 Newton per metre squared?
Yes, yes.
And back to that British standard, and you mentioned basements before. Do you think that the British standard only applies to depressurization systems in basements?
No, it says typically rather than always. Yeah.
We can perhaps look at what it actually says at paragraph J5 2.22 of your report. That's BLAS 5031 at page 34, where you've set out a key part of that standard. If we just zoom in on that.
Oh, that's a different part. Yes, yep.
And I think, and is it right that it gives an example? We see that in the second line of a basement. So it said the objective of a depressurization system is to achieve the same protection at the doorway between the depressurized space, e.g. a basement, and the protected space.
Yes.
Is that right? And in the very last part of this extract from the British Standard, it says the last sentence, the most appropriate use of depressurization systems is likely to be in basement spaces, see figure 18. So is that why you said most frequently used in basements, but you don't think it's only confined to basements?
Yes, and I think that's got to do with just the earlier sentence, bounded on all sides by fire-resistant construction, just slightly up there. To be effective, each depressurised space shall be bounded on all sides by fire-resistant constructions, because any loss of integrity would result in equalisation of pressure between the depressurised zone and the external air. So to cut a very long story short, if a window can break, the balancing of your system is lost. And that's why in a basement space, that risk isn't there.
Yeah.
Okay.
And is that why it's so important to know what you're doing about doors being opened? That we'll come to in a moment.
And we'll come on to that.
So if you open more doors, it's going to affect your calculations.
Exactly. It's the purpose of all your design decisions are to create what I would call a balanced system with the correct openings allowed for.
Now, is your position that British standard that we're just reading from could be viewed as setting out functional objectives or measurable performance requirements which could be used to assess the adequacy of a pressure differential system as against the building regulations? Is that one way you could use it? I'm not strictly following every letter of it, but looking at functional objectives or performance requirements that it's setting.
Yes, I do. It actually is very clear on functional objectives, particularly when it gets to explaining where the smoke should not go in terms of a single stair and lobby used for firefighting. So I think that British standard is very clear on functional objectives, and then it gives additional guidance on how to achieve them.
Now, is it right that you've said in your report, in your latest report, that you'd like to be provided with evidence from the design team at phase 2 about what route to compliance they thought they were adopting, and that you will review any such evidence before you reach any final view on compliance of the system?
That's correct.
And I think you've already accepted that the building regulations required the system to be no worse than the original smoke vent system.
I don't accept that, no.
But you haven't considered anything to do with the non-worsening principle yet?
I haven't done that, and it will be interesting to see the calculations as to what the original mechanical extract system could do relative to this version now.
Would you agree that a smoke ventilation system using pressure differential principles is not the only type of mechanical ventilation system which could be considered acceptable to comply with the building regulations?
Yes, I do.
And do you agree that tailor-made solutions can be appropriate?
Tailor-made solutions that deliver on the required life safety objectives and fire safety objectives, yes. And this British standard is very clear that the stair and lobby are to be kept safe for firefighting purposes when the flat door is open and multiple other doors are open at the same time.
Yeah. Would you agree that most smoke ventilation systems are usually bespoke and that they don't use natural ventilation or pressurization or depressurized principles?
No, I would not.
Would you agree that there are known alternatives to such systems, such as the BRE shaft system or the Colt shaft system?
I'm aware that they exist.
Are either of those similar to what was installed at Grenfell Tower?
I don't want to answer that question at the moment.
Because you don't have enough information?
I don't have enough information, and I haven't done a proper comparison of those systems to give my view. I'm happy to do so.
Could such systems comply with the functional requirements of the building regulations in principle?
If they were designed and installed appropriately.
Okay, so I want to what I'm going to do is just turn to your current assessment of the system, and then and just look in general at that. And then I think before we get to smoke dampers, we might take a break. So if I can just do a few more questions before that. So what you have concluded, is this right, is that the system appears to have been intended to comply with one aspect of that British standard, namely the airflow performance of a Class B pressure differential system as defined in that spec?
Yes, it refers to the airflow across the stair to lobby door. and it also refers to the correct force to allow one to open that door.
But it's, as I understand your evidence, you consider that there are 5 key requirements for a Class B system, not just that airflow performance, and that includes a pressure differential criterion, is that correct?
Yes.
We can see those 5 key requirements listed out in your paragraph J5.2.16. If we could just bring that up. That's BLAS 5031 at page 33. And so you've listed them out.
Yeah, that's easier. So a Class B pressure differential system is for the purposes of protecting a firefighting stair and lobby. Mm-hmm. So, and there's some, and so it requires the designer to consider the flat door being open, the stair door on that lobby being open, as well as the stair door below, and also there's requirements for the lift. So the door, there's rules for providing the right pressures, and there are multiple requirements, the right airflow, and there are multiple requirements, also air supply, and various other things. So altogether, they provide a ballast system that keeps smoke away from the lobby and stair as a result of it flowing out of the flats.
Yeah. Can we go to your figure J50? I think this is where we see a good diagram that you've marked up of the refurbished system.
Yeah.
That's BLAS. That's it. Yeah. If we can blow that up. So there, this is your attempt to try and explain the programmed operation of the smoke control system. Is that correct?
Yes, that it operates on one floor.
Yeah.
And the smoke is extracted down the south shaft and up the north shaft.
So that's what. So we see it going out of the south shaft,
yeah,
up and out of the
up
north
at the
shaft.
roof. Yes.
Removal of the air from the lobby.
Yes.
And you say design intent 2 meters per square through the one open stair door.
Yes, yeah. Exactly. So that airflow was designed for with the stair door open, that the system would cause that airflow at that door and prevent the smoke flowing into the stair. But in this design, no other door being open was provided for. So everything was shut except the stair door.
Yeah.
If the system is operating, it's taking air out of the lobby,
yes,
in 2 different directions.
Yes. Yes.
To that extent, it's exerting some degree of pressure on the stair door to
yes.
keep it closed.
Yes.
The stair door ought to be fitted with smoke seals.
Yes.
But it still lets enough air in, does it, to compensate for the loss of pressure in the lobby?
One has to make that decision during design, how you are going to allow that release of pressure. So you can open the door.
In layman's terms, you've got to get air from somewhere.
You certainly do.
And it could come from the flats surrounding the lobby.
Yes.
Whose doors may not be...
Correct.
Or won't be airtight.
Correct.
But should be smoke tight.
It should be. Same with the stair door, or you might provide air release act. You might provide something specifically in the lobby to allow that air release. Okay.
But as soon as you open the door to the flat where the fire is,
yes,
you are inevitably, again in layman's terms, sucking combustion product out of that flat.
That's correct. Yeah.
Yeah. All right. Thank you.
Yes.
And just back to how this was meant to work, so as you explained earlier, the environmental system was to deactivate, shutting down and isolating the environmental fans at lower level.
Yes.
And then the automatic opening vents on the fire floor only were to open.
That's correct.
And all other floors, the automatic opening vents were meant to stay shut.
They were to shut if they were open or stay shut.
And the role of those dampers, we're going to come back to those in a little bit of time, but they are to stop the flow of air through a duct. Is that what a damper does? So we have dampers all the way up, don't we, on the AOVs, behind the AOVs?
So those dampers shut to seal that riser. It's almost like closing the compartment. And so it prevents anything leaving the duct, ideally, as it's moving down to the south, up to the north. Mm-hmm. That's one reason why it's sealed. And it's also acting as the wall, if you will, to prevent fire and smoke products from other floors. So dampers it's like a door sealing a compartment again. You're closing a hole in a protected riser.
Yeah. Now, in this diagram, you've identified some concerns you have about the way the system was set up to run at the bottom in little red boxes.
Yeah.
Are any of those likely to have made a difference on the night, given that?
I don't know, and I've made clear in my report what I need to know. It's either just a paperwork error, so the papers I have aren't up to date. But at the moment, it doesn't look, based on the programming in the panel, it doesn't appear there's a proper power supply in and out of those dampers. Yeah. But that's why I've asked for documentation to confirm either way.
Yeah. Now, I just want to try and summarise your current views about the design of the system based on what you've seen to date.
Yeah.
So you've said that at Grenfell Tower it was a system whereby each flat should have been a depressurised zone, but in fact it was a system which depressurised the lobbies relative to the flats and the stairs.
Yes.
And that's not a system envisaged by the British standard. Is
not
that
as I understand it.
And you say that the airflow criterion in the British standard is that a minimum airflow of 2 metres per second is through the open door between the lobby and the fire flat must exist. But is it right that the design at Grenfell was such that the system was said to provide an average open door velocity with no other open door conditions?
That's correct, as I read the technical specification, yes.
So you have a concern at the moment that there may have been no allowance for the fact that both the flat door and the stair door might have to be open during firefighting operations, and the system should still be able to deal with that and cope with that.
Yes, that's the whole functional point of a Class B system, which is to aid firefighting.
And you've also referred to the fact that it provides for a single pressure differential of minus 25 pascals, which was not referred to in the British standard.
That's correct.
That referred to pressure differential requirements at 3 different locations.
Yes, it did.
And that the British standard required 4 more performance requirements for a Class B system, which we just looked at.
That's correct.
And you also say, since it was based on kind of depressurization principles, there were 10 separate additional requirements which you've looked for and you've not found.
No, I haven't.
Only one you think may have been met at this stage.
Yes, that's correct.
And is it right that your fundamental concern is that in a depressurization system, the flats should be depressurized relative to the stair and the lobby, but at Grenfell Tower, the lobby was depressurized relative to the flats and the stair?
Yes.
And is the concern that this might draw smoke into the lobby, both from the flats and also the stair?
Yes.
And that's your conclusion?
Particularly the flats, yes.
And what about if other flat doors were open onto the lobby?
Exactly.
Is that something that also should have been thought about?
Well, because of depressurising that zone, the more doors you open, the more the zone is impacted.
Yeah.
But the other flat doors, which are not affected by fire, will simply give you a better airflow, won't they?
It's not just about airflow, it's about pressure balance as well, and the fans are connected to pressure sensors.
Right.
So everything changes all the time in a pressure differential system.
Yes.
Yeah.
So it isn't just that there's good airflow coming through the flat door. It's how the pressure balance is then impacted and what all the resulting flows are near the stair. It's
But just to be clear, you've not formed any final view on compliance in relation to this, and you would like to hear from the design team
Yes, I would,
at
please.
phase 2, so you can understand
Understand
how the
all-
system was meant to
Exactly.
work
Yes.
and how they were complying with the functional requirements of
Yes,
the
because
building
as I read
regulations.
it now, I don't understand it how at all it could be a Class B system.
Thank you. Mr. Chairman, I think that's a good time for a break because I'm moving on to another subtopic within this. But I think we're still in good shape to finish.
Well, we're going to either have a slightly short break or a slightly long break.
I would suggest that we have a slightly longer break and then I aim to then finish. Oh,
All
well,
right.
we'll have to have another break. Right
No,
at
no,
the
I
end.
don't think we need another one after that. Will we?
Well, I'll have to mop up any questions.
Oh, well,
So,
that doesn't really count. No. I think we'll have a slightly longer break, otherwise it'll be very short.
Okay.
I'm going to stop now for just over 10 minutes.
Okay.
Give you a
So
bit of a break.
25 past.
25 past,
Right.
exactly. Yes. All right. Thank you very much. Good, thank you. 25 past 3, please. Thank you. Yes, no.
Yeah.
Ready? Yes,
Yeah.
good.
Yes. Thank you.
Could I just add to something
Yes, of
from
course.
earlier? It's good to have a coffee break sometimes. So I think I should be clear that when a system based on pressure differentials is being allowed for, the S requirement for fire doors is not provided. So the smoke seals, okay?
Oh, right.
When in a new building.
Yes.
And the second thing I should have said is the fans are connected to a pressure sensor, which is monitoring the pressure difference between the stair and the lobby all the time. And so the fans, you could say they're changing.
Yeah.
You asked about what happens if XY doors start to open. So all the time it's
Yes.
monitoring that pressure difference. So it's not a steady state system,
It's much more sophisticated than I gave it credit for.
potentially. Yes, it's much more complex anyway. Yes.
All right. Thank you. Yes, Miss Grange.
Thank you. Yes, I want to move to the topic of smoke dampers now, and because you've raised some concerns about those in your report. Can we
Yeah.
just look at a picture of what we're talking about? I think there's a good one in your presentation of the 18th of June. If we go to page 176 of that, that's BLA 405481 at page 176. Now, have I got this right? So these are, you've got them as rotating blades here.
Yeah.
Can we see, can we see the dampers on here?
Yes, I can. I think they're from the new floors, but
Yes,
but
the
they're
principle.
dampers.
I'm just trying to
Sorry,
get the
yes.
principle
Yes.
of what a damper is. If
Yes,
you can just
exactly.
explain to us.
So it's a metal mechanical device that can be controlled into the shut position on the right.
Yeah. So we've got the open on the left and the shut on the right, and
Yes.
it's meant to then provide a seal so that the smoke going behind it doesn't leak through. Is that correct?
Where a seal is required.
Yeah.
And so, yes, because in other buildings a seal may not be required.
I see.
Yeah.
And you've explained in detail in your report that because the smoke extract system was a powered pressure differential system,
Yes.
that these dampers were required to meet certain enhanced standards for smoke-controlled dampers
Yes.
to ensure that they achieved a 60-minute rating for integrity and smoke leakage. Is that
yes,
correct?
because they're in a lobby in a residential building.
Yes.
Yes.
I understand. And you've explained in your report that the smoke dampers in the north and south shafts were Series 54 smoke dampers manufactured by a company called Gilbert's and supplied to Rydon's subcontractor PSB. Is that correct? But now you've identified some evidence in your most recent work which would suggest that these dampers weren't tested to the relevant enhanced standards for smoke control dampers. And indeed, it would appear that they weren't properly tested to certain lower standards. Is that correct?
Yeah, so they've actually failed the smoke leakage test, and they were not tested in the proper, I'd say, position in the fire damper test.
Is it right that in order to satisfy the requirements of that lower standard, they had to be tested from the open position, and if they take a certain amount of time or in excess of 2 minutes to close, the test has failed?
That's correct. It has to show it can do its opening and closing action in the test.
And was the ability of a damper to close effectively on all floors away from the fire on being subjected to heat and smoke fundamental to the performance of the smoke control system at Grenfell Tower?
It was fundamental to the function of the builder's ducts acting as an adequate compartment.
So these are the shafts, the builder's ducts that have been used as the shafts,
Yes.
particularly the north shaft, to
Yes.
extract
Yes.
the smoke away from the lobby.
Yes.
These are what protects
Yeah.
the lobby on all floors.
On all floors,
And on-
exactly.
On the fire floor where it's working, it opens.
It opens, and that's absolutely fine. The products of combustion can enter, but then those products have to be kept within that protected riser. They cannot exit on any floor.
Yeah. And is it right that you have picked up that there is some evidence from the BSRs which would suggest that smoke was entering the lobbies via these kind of smoke vents on particular floors?
There is some evidence on some floors that smoke was observed to leak from the location of the builder's ducts.
And we had oral evidence from Farhad Neda in particular in relation to that, is that correct?
Yes, we did.
And do you think that that evidence is potentially important in the context of the problems that you've identified with the dampers?
Yes, I do.
And could this potentially indicate a failure to comply with compartmentation rules for protected shafts?
Yes, it could.
Do you think there are any other potential explanations that you're aware of at this stage for what Mr. Neda says he witnessed on his floor?
Yeah.
Could it have been anything to do, for example, with the firefighters operating the HMI panel? I mean, is that possible?
So this is a recent piece of evidence for me, and I've set out in Appendix J all the things I now want to look at. I don't have any evidence, remember, that the firefighters actively opened or shut dampers on any floor.
Now, Professor Torero, in his evidence, was asked about the potential smoke leakage onto the lobbies through these dampers. And he said this, he said, well, the evidence is that the system is performing poorly because it's bringing smoke into the lobbies. Now, that could have been because of the non-compliances, but it could also have been because the system was designed to basically deal with one floor. And I think what he was implying is that if you've got a fire and multi-storey fire across the building, that potentially that system is dealing with a quantity of smoke that it wouldn't have otherwise dealt with. The question for you is, would you have expected the system, particularly in terms of leakage through those dampers, to have coped with those smoke levels?
Okay, so can we just break that down a bit? So the system isn't dealing with a fire on multiple floors in the sense it's not meant to be open on multiple floors.
Yeah.
Okay. So at the moment, therefore, I don't understand Professor Torero's issue, say, about smoke quantities. Right. The system, as a protected riser, is required to provide compartmentation for a certain period in every lobby.
And that's 60 minutes?
Yes, it is.
Yeah.
Yeah.
So
there are other pressure imbalances that might cause flowing of smoke out at level 23 particularly. But as I've said, there's all sorts of different things I must consider before I offer up any kind of opinion on why the smoke leaked on certain floors.
Yeah.
I am clear in my own mind about the damper performance, but there are other things I must consider too.
Yeah.
Mm-hmm.
And there's potentially some other written evidence. For example, Daniel Griffin, in a witness statement that's read out to the inquiry, refers to smoke spread via the vents into the 6th floor lobby.
Yes.
Is that something that you will want to look into?
I have been thinking about, yes, I am considering that.
So in terms of those smoke shafts on the north and the south side, you've also highlighted some potential issues around those shafts. Is it right that so they were retained in the refurbishment? They were originally builders' work shafts serving the north and south sides of the lobbies. Is that right?
That's correct.
And you've examined them. Can we look at figure J16 of your report, BLAS 5031 at page 56?
Yes.
And I think what we see, I just want to look at a number of these figures, is you have concluded that neither shaft was rendered nor was it metal lined. Let's just stick with rendering.
Yeah.
Does that mean kind of cemented to make it a smooth surface?
Yeah, so when when someone like me wants to rely on the builder's work shaft for a smoke control system, both the British standard and actually the Smoke Control Association guidance makes clear, A, that's perfectly appropriate, but B, there are certain checks you have to do. So it's about making it as smooth as possible and also checking if it leaks just by nature of its current condition.
Yeah. And if this was leaking, this shaft,
Yeah.
what are the potential candidates in terms of where it leaks to?
Oh, okay. Well, I would need to show you on a plan, but the walls here that we're looking at for the builder's duct are in the flats.
They're in the
beside
flats?
it. Yes,
Yeah.
they are. Near, well, it depends which flat, but they're near the front door. Yeah.
And you've noted that it wasn't metal lined either. Is that something you sometimes see in a smoke shaft like this,
Yes.
that you will metal line the whole thing?
So if you can't, apply a smooth finish, it might be that a designer would choose to provide a lining instead.
Yeah.
But it has to be contemplated, is the point I'm making, in terms of then preventing so much friction when the fans switch on. Okay, it's trying to get the smoke up easily.
And you've drawn attention in this particular photograph to mortar joints between blocks, which you say are visible, and then you've got same diagonal line pattern as exhibited on outside of shaft.
Yes, I just observed. I was trying to say that it's not been covered with something else, from what I can see.
And can we just
the mortar joint is a good thing in the sense that means it is sealed.
Right. Yeah. And can we just look at a couple of other photographs after this, in J17, which is on the next page?
Yeah. So again, just trying to say that I can see an external surface rather than a surface that's been covered with something else.
Yeah. So this, to you, is this concerning that you're seeing it in this condition?
On the inside, I would like to understand how the lining of the builder's work duct and its leakage was considered by the design team and factored in to the final design condition they provided.
Because you say at the moment you've not seen currently on what you've had any evidence that it was checked or tested during the refurbishment.
That's
is that
correct, based on the papers given to me.
Let's just finish off if we look at J18 and then J19.
Yeah. Yeah, I mean it's the same. It's the same
point.
Thing again.
Yeah.
Just trying to show what's there, so people can have that transparency.
And those builders' works ducts should have had a 1 hour fire resistance, I think you say.
The lobby, well, as an extension of the lobby, it should be 2 hours, but the dampers are 1 hour for the floor-to-floor separation. And yeah.
In terms of the contribution of these kind of issues, with the dampers and the shafts, let's just think about them, and the contribution they potentially might have played to smoke spread in the building. Given the scale of the fire and the fact that we know that numerous flat front doors did not have functioning door closers or the doors were left open, isn't the most likely source of smoke in the lobbies to be due to the failure of the doors as people escaped into the lobbies, rather than these kind of compartmentation failings?
So I have to say what I said this morning. So it depends which lobby it is, where there may have been lobbies where the doors were not left open or opening very frequently, and smoke spread by other means is relevant.
Commissioning. Now, you have looked at the available commissioning documentation that you've seen to date for the system.
Yes.
And your view is, I think, that you say that the building regulation requires the works to have been carried out such that they can adequately perform the functions for which they're designed. Does that mean, in your view, that such systems need to be properly commissioned so as to demonstrate the adequate performance?
Yeah, to comply with Regulation 7.
And on the basis of the commissioning documents you've seen to date, is it right that you have concerns about the commissioning process that was followed?
Yes, I have.
Now, the detail is in your report, but in summary, is it right that you've looked at relevant guidance for commissioning, including the Smoke Control Association guidance, and you can't see evidence that all the relevant checks were carried out when commissioning the system?
Yeah, that's correct.
Now, in terms of the evidence of its operation, both before and on the night, and whether the system was operating properly, you have said in your latest report that you want to revisit this in phase 2, given the wealth of evidence that you've heard from firefighters and BSRs about the operation on the night.
That's correct.
I'm therefore not going to put any points in detail about this, except to just look at a few points on the extent of what you have examined. You say that you know that the system worked in some way on the 4th floor because the building management system triggered an alert to Tunstall.
Yes.
That's the remote monitoring platform at 0054, is that right?
That's correct. So I know, we know that happened, and I assume it was because of smoke at level 4 because of the time that that signal was sent. But I don't have any information, remember, about how that whole remote monitoring system actually works. But we know a signal was received at a certain time, and there's no reason to think there was smoke anywhere else at that stage of events, so before 1 o'clock.
And that would be smoke relevant to the fire in flat 16 at that point?
Correct.
Is that correct? Now, you've referred to some resident evidence, resident Ahmed, relating to smoke coming from the level floor lobby into the stair.
Yes.
And you say you're concerned that this might indicate that the system was not functioning as intended. But do you think it's going to be necessary to look at all of the evidence, including the firefighter evidence we've now heard, some of which might suggest that the lobby was less congested with smoke in the early stages?
Yes, that's correct. So there's evidence of limited smoke in the level 4 lobby, and then things changing. And this issue of doors being open and closed and where is very important. So all the very detailed breakdown of early firefighting activity, I'd like to compare that then with the different evidence about the conditions of smoke at level 4 and in the early stages when that was a single fire condition and if the system operated as intended.
Yeah. And you say in your report, so you've been able to look at the programming for the smoke control system,
Yes.
and you say that it does appear to have been correctly programmed to respond appropriately to the detection of smoke on level 4, is that correct?
That's correct.
But you're unable to say on the night precisely which pieces of equipment activated, as the system activation log in the HMI panel was overwritten by events after the 14th of June, before it was seized.
That's correct.
And therefore is no longer available to you. So we don't have the data from the night, is that the point?
Yes, so very unfortunately we don't know the order of devices triggered. And the software being correct is one positive thing, but then it means what it's controlling needs to physically be able to perform also. So there are two, when you're checking a system in terms of handing over a building, does the software trigger the right devices at the right time, and can they physically react to the programming?
The fact that that data is not available from the night, is that a significant gap in your knowledge in terms of how the system operated?
I think it's very unfortunate.
And do you think that's going to hamper a conclusion about whether the system did operate properly? Or do you think there are other things you can look at?
So it would have been the most useful piece of data, but instead, and I've listed everything out at the back of Appendix J, there's all sorts of other data now I need to consider.
Yeah.
Noise, physical observations up at the roof, from the helicopter footage. There's all pieces of data now that I need to piece together to understand if smoke indeed entered the shafts and left the shafts at the roof, and remember down at level 2 above the door.
And you've also analysed at this stage the available firefighter evidence as to their attempts to operate the system.
Yes, I have.
And you've also reviewed the instructions available to the firefighters in the lobby next to the HMI panel.
Yes,
is that
I have.
correct? To look at their clarity.
Yes.
And we should bear in mind, I think, is this right, that so the system operates in automatic mode when it's detected on the fire floor, and it should operate automatically.
Yes.
But there was a function, and there were various instructions given about how the firefighters could override that and select a different floor.
That's correct.
For the smoke control system to operate on, if they wanted, for example, to operate it on floor 11 as opposed to floor 4.
Yes, so so the system provides 2 ways to do that. You switch the panel to on, and there's a touch screen that allows you to pick a floor to change the function, to change the floor of operation, or you switch to on and you go to the floor and use the yellow key switch in the lobby. The instructions actually only offer going to the floor with the yellow key switch as they were printed out underneath the panel on the night.
Yeah.
And I don't know why that is.
I just wanted to ask you about a few things to do with these instructions. You've said in your report that the instructions to access the damper status are clear. So that's to look at what was happening for each individual damper on each individual floor. Is that correct?
Yes, it provides that function. Yes.
But you say that the damper status indicators might not be providing accurate information because what you've identified is that the switches from the dampers may not have been connected to the system, so that what you're seeing on the screen may not be telling you accurate information about the dampers.
Yeah, exactly. You can get this kind of return signal. So the damper tells the controller, I am open, I am shut. And that was disconnected in the tower.
Can we just go to that? That's BLAS 5031 at page 141. That's J9. If we go to J9.4.10. So I think this is where you explain that point, how 4 lines down in Grenfell Tower these switches were not connected to the system. Yeah. Can you just explain the basis on which you've concluded that they weren't connected to the system? How do you know that?
Because the wires are bundled and tied together.
Right. And I think my next question falls away. Yes, and you've just made this point. You also conclude that the instructions state that only one floor can be controlled at once, but do not state that the user must turn off the key at the floor of operation before another key switch could be operated to change the floor.
That's correct.
So if someone's put their key in the little yellow box in floor 11 and they want to change it to floor 12, the instructions don't tell them that they've got to take the key out of floor 11.
Yeah, they have to turn it off. Yeah, exactly.
And
you
then,
have to finish your operation there and then go to another floor. Yeah.
And you've also pointed out that the restart system option would restart the system on the floor of activation regardless of whether a key switch had been operated. Is that right?
Yes.
Do you think these instructions were as clear as they should have been to guide firefighters
I do
on
not.
the night? And is it right that at phase 2, in terms of the work you're going to do, you're going to review the operation by the firefighters of the system on the night to try and look at what they might have done?
Yes.
And you say that it was found in the key to the HMI panel on the ground floor was found in the on position rather than in the auto position.
Yeah, that's correct. London Fire Brigade provided a photo of the key in the on position.
But you say it's unclear how or precisely when that happened, and there's no evidence that anyone did that intentionally. Is that right? Or shut down the system intentionally?
Yeah, so I don't know when that happened, and I don't know if either the touch screen or the yellow key switches were then also used, as they could have been when the main key was in the on position.
Yeah. And do you intend to review the CCTV footage further in terms of those considerations?
I will review it further, and yes.
Now, Watchman de Dowden appears to have used a key to activate the yellow key panel in the lift lobby at ground floor. We've seen pictures of that. Based on your review of the software and how the system was supposed to operate, what would be the effect of that, of putting the key into the ground floor?
Well, it depends what the condition at the main HMI panel was, and I don't know if it was in on or not when he did that.
If it was in on, would the effect of him putting his key into the yellow key switch mean that it was diverted to operate on the ground floor?
Theoretically, yes. It should have opened. It should have opened the vents at ground floor.
Now, just generally in relation to that override facility in the smoke control system, are you aware of the LFB policy guidance in GRA 3.2 that the incident commander must not make any changes to a high-rise building's ventilation or fire safety system without first taking appropriate advice from either the responsible person or appropriately trained fire and rescue authority personnel?
Yes, I'm aware of that.
Are you aware of any attempt by anyone during the course of the fire to seek advice or assistance from the responsible person as to the way in which that smoke ventilation system was supposed to operate?
That's not something I've looked at yet, but I will be looking at those types of activities when it comes to duties regarding the regulatory reform fire safety order, which I haven't done yet for responsible persons.
Now, in relation to the performance of the lift doors,
yes,
your site inspection and report make no observations with regard to the performance and conditions of the lift doors, despite the fact you've noted that the doors were seemingly not specified as fire rated. Do you think that in order to fully consider possible smoke contamination routes, it's going to be important to have regard to the lift doors?
Yes, I would like to have had the opportunity to do that, and I'm sure the lift expert can do that work.
If we leave aside the damper compartmentation issue for a moment and simply assume that the system was compliant, but it didn't work on the fire floor on the night, would you agree that that would have limited effect on the spread of fire and smoke throughout the building?
Its role is to stop smoke entering the staircase during early firefighting.
So does that mean you wouldn't agree with that, that you still think a compliant system...
A perfect system designed to either extract smoke or limit smoke movement on one floor obviously cannot operate on all floors simultaneously unless such a feature was provided.
And finally, I just wanted to look at your section J11, which lists out all the further investigations that you wish to do as part of your phase 2 work. Can we go to BLAS 5031 at start with page 152?
Yeah.
And we don't have to go through all the detail of this, but is it right that what you've done in this last section is set out all the different work strands that you would like to do in order to understand better the system and whether it operated correctly on the night and what the consequences were?
Yes, exactly.
So if we just go, you've got considering whether there's any evidence of noise from the fans.
Yes.
So all those questions that poor Mr. Rawat had to keep on asking about noise of fans, they're potentially important to you, is that right?
It's very important, and to understand if either firefighters or residents could hear these noises. The problem about fan noise at Grenfell Tower is the system was a combined system.
Yeah.
So,
and if we go over the page...
Sorry, did you finish?
Yeah, so I won't be able to rely just on noise.
But these are all pieces of a jigsaw.
But all the different pieces, yes.
And then you've got considering when there's any evidence of air movement, analyse the data from the post-fire condition of the smoke control system.
Yes.
You refer there to LFB Officer James Flynn taking photographs.
Yes.
And I believe he's also provided a witness statement,
Yes.
which you'll have to look at
Yeah,
as well.
I'll go through all of that. And also, I think the thing I'm most interested in is where soot was actually deposited. I think
Yes.
that's a really good piece of physical evidence.
And that's where, so Professor Steck of the University of Central Lancashire, who's been appointed as an inquiry expert, she's done an investigation of soot deposits.
Yes.
And she's done a short summary, but you want to look in more detail at that.
I do, because, you know, is there soot all the way up to the roof? Is there soot all the way down to level 2? Is there soot on the fan at level 2? Etc., etc. And all of those things will allow us to understand if there ever was smoke in the system.
And do you agree that it's going to be necessary to establish an accurate timeline in relation to internal and external smoke spread before you can reach any more definitive conclusions about whether the system operated as intended?
Yeah, I think that study is very important for a multitude of reasons. I mentioned the lifts getting filled with smoke earlier and all sorts of other things. Yes.
Thank you. Mr. Chairman, those are all of my questions.
Right. You'd like a chance to consider your homework.
Exactly. So if we can just have a break, maybe for 10 minutes.
Yes.
Well, 9 minutes. Let's go
Well,
5
let's
past.
say 4:05.
And then if there are any further questions.
This is
Do
really,
I need to leave? Oh, yeah.
well, it's usually convenient because other people may want to talk to council.
Okay,
So
right.
we'll both leave and
Okay.
come back at 4:05.
Okay.
All right?
Thank you.
Thank you very much. All right, 4:05 then, please. Right, Dr. Lane, well, I haven't asked Miss Grange whether she's got any more questions, but I suspect she has.
Only one.
Only one?
Which is good. About the roof. It's a question I put to Professor Torero, and I should have put it to you as well. Do you think on the night that the roof might have provided a refuge for occupants of the tower had it been able to be accessed?
When I was in the roof, I observed areas that were not impacted by fire and smoke.
So does that mean you think it might have been able to be a refuge?
Well, it's hypothetical because it was inaccessible.
Yeah.
It is something that I do consider as such in my own work. But it was locked and inaccessible,
Okay.
as I understand it.
I think the question asked you to assume that it was not.
Was it?
locked.
I know.
Yeah.
I find it, I just have that kind of brain. It's hard for me to do that.
Yeah.
So all I can tell you is I observed myself. There were areas not impacted by fire and smoke, and that's actually quite upsetting when you see that. But I don't know how it could have been actually used. I don't know the answer. I don't know how to answer that question at the moment.
Do you think the proximity to the crown may have been an issue in terms of accessing the roof? Because as I understand, you come up and you're out onto a lower parapet.
That's correct.
Around the outside, right adjacent to the crown.
That's correct.
And then if you want to access the inner
You have to go up
roof,
further.
you have to go up a pretty
Yes.
scary ladder.
So I'm happy to explain the access points and the location of the hazard when I'm doing that part of my work, and I will be much clearer then.
Yeah. Dr. Lane, those are all the questions that we have for you. I would just like to thank you and your team. All of our experts have worked incredibly hard within the timescales, but that really does particularly apply to you and your team. I think only we as the inquiry team know quite how hard you have all worked to produce the detailed report that you have, and I just want to give you our thanks, because we know an awful lot of blood, sweat and tears has gone into the writing of that report.
And I just do want to say thank you to my own team. They have worked tirelessly for a very long period of time. So, but we were very happy to do so.
Well, we are very grateful to you, because one can see how much time and effort has gone into this work, and you giving us your opinion. I mean, it's a very substantial report.
Thank you very much.
And we are very grateful to you for putting your expertise at our disposal.
Thank you very much.
Thank you very much indeed.
Yeah.
All right. Well, that's all. So you can go with the usher if you'd like to. Thank you very much. Right, Miss Grange, that's perhaps it for the day, is it?
It is. I think we have Dr. Glover tomorrow.
Yes.
Yeah.
So more expert evidence tomorrow in the form of Dr. Glover.
With Mr. Kinnear.
Yes, good. Well, thank you very much indeed. 10 o'clock tomorrow then, please. Thank you.